Today we will be talking about section 5.7 in your book, entitled The Fundamental Theorem of Algebra. The first important fact to know is that if f of x is a polynomial of degree n, then the equation f of x equals 0 has exactly n solutions. Repeated factors count as separate solutions in this case. So let's start with an example. How many solutions does x cubed plus 5x squared plus 4x plus 20 equals 0 have? Since this is a third degree polynomial, that means that we'll have 3 solutions. Another way of asking the same question is to say, how many zeros does the function f of x equal x cubed plus 5x squared plus 4x plus 20 have? Once again, this is a third degree polynomial, so it has 3 zeros. How many zeros a function has is equivalent to asking, when does the function equal 0? So all you have to do is look at the highest degree term, which in this case is 3, and that's your answer. Now finding all the zeros is another task. So now that we know how many zeros there are, once again in this case it's an x cubed polynomial, so we know there's 3 zeros. We need to find out what those 3 zeros are. In other words, what are the 3 different values of x that when we plug any of them into this function, it equals 0? One way to solve this is to look at the constant term and the coefficient of the leading term, and every possible 0 will be a factor of the constant term divided by the leading term. So for example, plus or minus 20 over 1, plus or minus 10 over 1, plus or minus 5 over 1, plus or minus 2 over 1 are all your possibilities. We can use synthetic division to test for each of these. Another way to do it, though, would be to look at your graphing calculator. If I graph that function, x cubed plus 5x squared minus 4x minus 20, and just hit zoom 6, we're going to look to see where this graph crosses the x-axis. And it looks like it's crossing it at -5, -2, and +2. We can hit trace to double check. Type -5, and sure enough, y equals 0 there. Type -2, once again, y equals 0. And then type +2, y is 0 again. You could also look at the table to see this. So your zeros occur at those 3 spots. So the solution to this problem is x equals -5, -2, and +2. Those are the zeros of that function. On the other hand, we can work backwards. If I tell you that a polynomial has zeros -5, -2, and 2, you can come up with the polynomial. You know that x equals -5 is a solution, x equals -2 is a solution, and x equals 2 is a solution. If we rearrange this equation, I'll add 5 to both sides. I have that equals 0. I'll add 2 to both sides. That equals 0. I'll subtract 2 from both sides. This tells me that the factors of my polynomial are x plus 5, x plus 2, and x minus 2. Because when I set any of those equal to 0, I get my 3 solutions. So my function f of x is equal to this. And so now I'm just going to multiply it out. X plus 2 times x minus 2 is x squared minus 4. difference of two squares. And finally, let me multiply these two sets of parentheses, and I'll get x cubed plus 5x squared minus 4x minus 20 by multiplying all the terms. So the polynomial that has zeros -5, -2, and 2 is the function f of x equals x cubed plus 5x squared minus 4x minus 20. Slightly more complicated one, we can start out the same way. I would go ahead and graph this function. You go to y equal in the calculator, and you punch in x to the 4th plus 4x cubed plus 7x squared plus 16x plus 12. And then hit a zoom 6 for the standard window, and look to see where this graph crosses the x-axis. It looks like it crosses at -3, -1, and that's all we can see. We might have to zoom out to see if there's places further along the x-axis where it hits, or this might mean that we have two solutions and two more are going to be what we call imaginary solutions. So let's write down what our two solutions are. First we'll make a copy of this, paste it onto our problem here. And so it looks like -3 and -1 are the solutions. So what we could do is some synthetic division. So -3, we have 1x to the 4th, 4x cubed, 7x squared, 16x, and 12. Bring the 1 down, multiply by the -3, add, multiply by the -3, add, multiply by the -3, add, multiply by the -3, 0 remainder. So this means that when I divide out the x plus 3 factor, I'm left with 1x to the 3rd plus 1x squared plus 4x plus 4. Now I'm going to repeat that process for the -1 factor. I have 1, 1, 4, and 4. Bring down the 1, multiply by the outside number, add, multiply by the outside number, add, multiply by the outside number, and add. No remainder. So this tells me that that was an x cubed, so I have 1x squared plus 0x plus 4. So right now, I have 0 equals x squared plus 4. To find my remaining 2, I'm going to subtract 4 from both sides. Could also use the quadratic formula depending on what your answer looks like. Take the square root of both sides. And I'm going to get plus or minus x equals 2i. The square root of -4 is 2i. So I'm going to get x equals plus or minus 2i. So my solutions are -3, -1, and plus or minus 2i. So x equals -3, -1, plus or minus 2i. There's 4 answers, and this was a 4th degree polynomial. And just like we did in the last example, on the other page, if I give you the zeros, you should be able to come up with the functions. So if I know -3 is an answer, I'll set x equal to that. Set x equals -1. I'll set x equal 2i, and x equals -2i. Setting each of these equal to 0, I'll get x plus 3 equals 0. That's one factor. X plus 1 equals 0. It's a second vector. x minus 2i, and x plus 2i equals 0. This means that my polynomial is going to have the factors x plus 3, x plus 1, x minus 2i, x plus 2i. And to get my final result looking like a polynomial, I would multiply all these out. So when I multiply the first two sets of parentheses, I'll get x squared plus 4x plus 3. And the second set, I'm going to get x squared minus 4i squared. We have to remember that I squared is equal to negative 1. So let me simplify this a little bit. This becomes x squared plus 4, because the I squared was a negative 1, so the negatives cancel. Now, if I multiply this out, I'm going to wind up with my polynomial, which, as we know, was x to the 4th plus 4x cubed plus 7x squared plus 7x squared plus 16x plus 12. So you should be able to find the zeros of a function, and you should also be able to find the function if I give you the zeros. Some of those solutions may be imaginary solutions, and when you have imaginary solutions, you'll always get two of them, or they come in pairs of two. So if you have a positive 2i for a solution, you'll get a negative 2i.